Unit 3 was all about triangle congruence, but the first thing we looked at was how to identify corresponding parts. So corresponding parts, in this case, would be like our angles. The 1 mark, angle A, would match with the 1 arc, angle F. Then we could say the same thing for C. Has 2 markings. It would go with D. That also has 2 markings. And lastly, we had angle B congruent to angle E. We could also say the same thing about the sides. So if we start with side AB, what would AB match with? So here's AB between 1 and 3. So what side does it match with over here? F and E, or EF. The other side, that's between 1 and 3. Okay, what about AC? DF, because AC has a 1 arc and a 2 arc, so 2 arc and 1 arc. And then lastly, BC would go with DE. So that's what we started the year with, just how to match up parts that went together based on markings. We also used the little tick marks to help us identify sides that were congruent. And we had to use to show all 6 things were congruent to say that the 2 triangles were congruent. But then we went into some shortcut postulates that helped us identify how to tell whether triangles were congruent without having to show all 6 things. Does anyone remember what one of our congruence postulates was? Side angle side. So side angle side angle side meant that we had to have 2 sides congruent. And see how the A is between the 2 S's? That means it has to be the angle between the 2 congruent sides that is also congruent. That would be our side angle side. What was another one? Side, side, side. So if we can show all 3 sides are congruent, then we would be able to say that the triangles are congruent. Okay, what's the third one that we did? No. SSA spelled backwards is a bad word.
Angle, side, angle.
Angle, side, angle. Okay, so we have 2 angles. So angle A and D, B and E, and the S is in the middle, so the side has to be in between the 2 angles. Anyone remember the fourth one?
Angle, angle, side.
Angle, angle, side. So 2 angles, but the side is not in between them, so it's the side not in between the 2 angles. And there was a 5th one. Anyone remember the 5th one? HL, hypotenuse leg. If you can show the hypotenuse of 2 right triangles and a leg of 2 right triangles are congruent, you can say that the triangles themselves are congruent. Okay, we also, after we learned these postulates and how to identify them, we did proofs with them. Your test will have proofs on it. Okay? There'll be the multiple choice ones where it's like half filled in and you have to just fill in the blank from the choices. So it'll say, why is triangle blank congruent to triangle blank? You'd have to look for one of these 5 postulates. We also had, with our triangle congruence proofs, something we could use called corresponding parts of congruent triangles are congruent. Okay, we used this to help us say, once we know 2 triangles are congruent, then we would be able to make a following statement that says side blank is congruent to side blank because they're corresponding parts of congruent triangles. It was one of our reasons that we could use after we've said 2 triangles are congruent. Okay. Is this starting to ring a bell? Is it bringing it back up to the forefront of your brain? Okay, we did a little bit more than just our triangle congruence though. We also talked about what an isosceles triangle was. So does anyone remember what an isosceles triangle was? A triangle with two congruent sides. So if we have a triangle, it has two congruent sides. What else does it have? Two congruent base angles. And the base angles are on the side that's not congruent. So if these are our two congruent sides, our base angles are on the third side. What about an equilateral triangle? What's all sides are congruent. What else? All angles are congruent. And what do each of those angles measure? They each measure 60 degrees. Because what's the sum of the interior angles of a triangle? 180. Okay, and I also just realized I forgot a theorem. So I'm going to squeeze it in real quick. Called the exterior angle theorem. Does anyone remember what that one is?
The exterior angle equals a certain number, but
The two remote interior, so these two on the inside, so in other words, not the one next to the exterior angle, the other two, x plus y will equal the exterior angle. Okay, that one comes up to help us when we have that angle on the outside. If we have a triangle, we might be able to use this to help us find it. Okay, we also did transformations in this unit. So, our rules for transformations. First, we had a translation. Our rules for translations were you took your x and you either added or subtracted something. You took your y and either added or subtracted something. Oops, that should be good. So if we had x plus 2, what would that tell us about a translation? It goes to the right because we added 2 to x. If we said y minus 3, what would that be? Down 3. So just by taking and looking at what's being added or subtracted to x and y, that tells us how far we move it up, down, left, or right. We also had reflections. We have x comma negative y and negative x comma y. So this first one, when we just switch the y value, that's a reflection about the x-axis. When we switch the x value, that's a reflection about the y-axis. And then we had our rotations. And they were all measured counterclockwise. So the first one, we switch x and y and make y negative. That represented a 90-degree counterclockwise rotation. If we kept x and y in the same spot but made them both negative, that was a 180-degree counterclockwise rotation. And then lastly, we had y comma negative x. That was a 270-degree counterclockwise rotation. And then lastly, what we did was we talked about what parallel and perpendicular lines were. Does anyone remember what's special about parallel lines? What do they have in common?
Slope.
Parallel lines have the same slope. Anyone remember the slope formula? M equals,
Oh, something x plus.
that's slope-intercept form of a line. That's y equals mx.
Minus y1 over x2 minus y.
Okay, you were thinking y equals mx plus b form of a line, where m is the slope and b is your y-intercept. But we can find our slope by using y2 minus y1 over x2 minus x1. And then what was special about perpendicular lines?
They're like even, like they like cut in the middle.
They do, but there's something special about their slopes that tell us they're perpendicular. Do you remember what the relationship between the, what is that? Opposite reciprocal. So opposite means negative if it was positive, positive if it was negative. Do you guys remember what reciprocal is? The flipped fraction. So if we had a slope that was 2/3, the perpendicular line would have a slope that's what? -3/2. So being able to recognize opposite reciprocal slopes. Okay, all of that was our first unit of the year. Any questions, clarifications, or things that you have at this point? Yeah.
For identifying triangles, if you don't have all three sides, or if you only have like an angle and then like one side mark, okay, like the homework, like right here, like number 1, would that be?
So remember, sometimes we have to look for information in the picture that that we know is congruent, but it's not marked. So if you look at number 1 on the homework, so she's looking at this picture right here. What can we mark on our picture to help us? Vertical angles. Anything else? That's the vertical angles. So we can, I don't want to write on this because this is one of the student copies. So we can mark those. So we have a side and we have an angle. Do we know anything else? So if we only know 2 things, can we prove that the 2 triangles are congruent? Nope. So what would your answer be there? D. Can't be proved.